is end behavior. End behavior means what does the graph look like when x approaches infinity and negative infinity? Okay, so when we're talking about infinity and negative infinity, we're talking about super huge numbers. So it's kind of an idea like, for example, let's say you have $1 million in your bank account. Let's say one day you lost 10 cents. Do you care? I hope not. Evan says he does. I hope you don't care about that because you have $1 million, you lost 10 cents. So infinity is the idea of $1 million. So when you're looking at $1 million squared plus 1, does plus 1 matter? No, it's too small. So what we're going to do is we're going to ignore numbers that's too small compared to infinity. So in this case, this really becomes 3x to the 4th over x squared. And then what we're going to do is we're going to simplify that. So that's 3x squared. So this graph, when it goes to infinity, it looks like 3x squared, like a parabola. All right, try this one. What will this look like when it goes to infinity? Oh, you guys are fast. Okay, so the 1 is negligible, so that's going to be 3x. It's too small compared to infinity. What about this one?
3.
Oh, wow, you guys are getting faster. I hope it's not just those two groups of people. Okay, what about this one? 3x over x squared, right? So that's 3 over x. 3 over x, while x is going to infinity, huge number. 3 divided by huge number is 0. You got $3, you gotta give it to $1 million people. How much money does everybody get? Almost nothing. Yeah, that's the whole idea. All right, let's try this. Let's start with Caleb. What is the domain?
Negative infinity 0 and then 0 to negative infinity.
To positive infinity?
Yeah.
Do we put bracket or parentheses on 0?
Parentheses.
Okay, Amelia, what is the range? No, there's a number we're skipping through. Trey, did you find it?
Do I need to do like the interval?
Or if you have other ways of writing it.
Is it y is not 1?
Yes, y is not 1. So negative infinity to 1, 1 to infinity. Now the question is, how do you know? If you graph it, and let's say you graphed it correctly because you got to put parentheses on here. If you didn't, you would be looking at a totally different graph from everybody. Okay, so x plus 1 divided by x. If you look at it, the graph kind of goes like this. So then there is definitely a place where it skips. Now, if you cannot figure or you cannot see that, there's another way to do it is looking at the table. If you go second graph, which shows you all the table values, you can see which number y should have skipped. If that doesn't work, then another thing to look at it is another way to look at it is it's basically the horizontal asymptote. If you think about it, remember horizontal asymptote has to do with the degree. The numerator degree is 1, the denominator degree is 1, so you look at the ratio is 1, so that means there is a horizontal asymptote at 1, and that is where it will skip. Most of the time.
Always use the horizontal asymptote.
Not always. Yeah, sometimes it does have a horizontal asymptote, however, it will cross it. So those are, so you have to check the graph to make sure. Okay, Iris, what is the continuity? Infinite discontinuity, yes. And then that's going to happen at x equals 0. Junior, what is the increasing interval? You don't know. How about Evan? Negative infinity to 0. Let me see. No. Okay, this graph looks like this. So where is the increasing interval? None. It's not increasing. Remember, we're going left to right. Left to right only. It's always decreasing. Okay, so then what is the decreasing interval? Let's try Evan again. What's the decreasing interval? Oh, okay. Huh? To, what do you think? Huh? To where? -1. No, not -1. Yeah? 0. Yes. Because it's the domain problem. Right? You're skipping 0 because it's the vertical asymptote, and that's going to be the problem for pretty much every interval. Anything you're analyzing is probably going to include 0 somewhere. Okay, Aaron, boundedness.
Oh, not bounded.
Yes, not bounded. Okay, Penny, local, absolute, extrema, and location.
Local.
Or can Andy help her?
I'm not sure.
You're not sure. Okay, what do you guys think? Anybody? For local, absolute, extrema, what do you guys think? There's none. Okay, how do you know if there is some or there is any? It has to change direction. If your graph is always going down, then there's no way it's going to have a hill or a valley, right? A hill means you have to go up and then down. A valley means down and then up. If it just keeps going down, then there is none. Yeah? Okay, let's try Tony and Andy again. Penny, horizontal asymptote. Look at the function.
Y.
Uh-huh.
1.
Yes. Okay, Andy, vertical asymptote.
Equal to 0.
Yes. Okay, Sally, symmetry. Odd, even, or neither? Sally, what do you think? Huh? Neither? That's correct. Oh, wait, did you say even? Oh, okay. It's neither. Now, if you look at it, you can tell it's going to, what kind it's going to be. First of all, it's definitely not even, right? Even looks exactly the same over the y-axis. Odd means that you turn it 180, looks exactly the same. It doesn't. It was, this part is was a little higher. When you turn it, now it's a little lower. So it's not odd. And so it has to be neither. Next, you have to remember how to prove this algebraically. So to prove that it is not even, or whether it's even or not, you have to show f of x equals f of negative x. This one is not going to work. Odd, you have to show that f of negative x is not even equal to negative f of x. Okay, so you guys show those. I am not going to do it right now, but you did it on the homework. In behavior, McKenna. No idea. You do. Yes. Oh, no. That's last year's. Last year, that's how we determine end behavior. This year, we upgraded. Remember this part? This is the end behavior. What function will it look like when x is going infinity? When x is very large, what will this look like? When x is very, very large. Yeah, I know you know. So I'm kind of not calling you. That's okay.
Is it 1?
Yes, it is 1. A lot of times it's just going to look like the horizontal asymptote. So when it goes very, very far away, it's just going to look like the horizontal asymptote. And then so this is kind of where we left off last time, where we said, what function will this look like? This, like for example, A, this function looks like this. And you can see that kind of looks like a parabola, right? So then when you basically zoom out a lot, meaning when x goes to infinity, it looks like 3x squared. That's the end behavior. So the end behavior means what happens to it, what does it look like at the end? All right, so what we're going to do today is review all our basic functions. The first thing is y equals x. That's very, very, very basic. The way I want you guys to remember, and tomorrow when you come in, is we are going to do some hand gestures. So also because that way you won't fall asleep in class. Okay, so y equals x. Everybody show me this. This is y equals x. Yes, thank you, Junior. You're not too cool for functions. Okay, so this is the y equals x function. Domain is all real numbers, right? Because you're going from the left to the right all the way. And range is all real numbers from the bottom up. Okay, next one. The y equals x squared function. This is the u. All right, everybody, show me y equals x squared. You guys are like right in front of me. Okay, so this is domain is negative infinity to infinity. Range, you can see that it's from 0 up. So it's going to be from 0 to infinity. Next one. Oh, no, not that way. Okay, y equals x cubed. This is where one hand goes up, the other hand goes down. Not this way. This way. Okay. So right hand goes up, left hand goes down. Everybody. Josh. Yes, I am preparing you guys for homecoming. If you have not, yeah, right? The homecoming, you do the function dance. Everyone thinks you're so cool. Okay, so the domain is negative infinity to infinity. Range is negative infinity to infinity. Huh? That's such a small absolute value. That's a little sad. Okay, this is the victory sign. This is what you do at this is what you do at homecoming, right? It's like goal or like, like what is this? You made the shot. Okay, everybody, absolute value function. This one, negative infinity to infinity, it's pretty much the same as x squared. You guys are looking ahead? Yeah. Okay. Please demonstrate. Yes, I can demonstrate, but this is hard to draw. Okay, so the right hand goes up like this, the left hand goes down.
Wow.
Yeah, this is years of practice. I have gotten my 1 over x down. Yes, this way. Right hand goes up, left hand goes down. This is going to be a very common graph for next year. Okay, I think this goes like this. I don't know how to draw this. I tried it second period. It didn't really work. Basically, we skip over 0 on this function. Next one, square root. This is... Okay, last year someone told me about this function. They said it was very interesting. I was like, oh, that's a good analogy. This is like, let's say a guy and a girl goes on a date. And then the guy is like, oh. Like this. So this is the, I like this girl. Yes, the one hand over. Whoa.
What happened to this?
Whoa.
Oh wait, yeah, sorry. Thank you, McKenna.
That's fine. And there's no other hand.
There's no other hand. Okay, so this is the square root function. The domain is from 0 to infinity. Range is also from 0 to infinity because there is a solid dot at 0, 0.
Stretching for this action.
Wait, do we have to know the domains in the range?
Yes.
Oh my god.
Yes. But once you kind of remember how it looks like, You should be able to figure out the domain and range. Okay, exponential. Okay, this one, I think of it as the underhand throw. Goes like,
Oh, that's smart.
yeah, so this is like the,
I don't have a place.
you throw it up function.
Oh my god, how are you?
Whoa.
Imagine doing this.
Stop.
I got laugh.
Okay. This is, if you look at the domain, it is all real numbers. The range, however, there is a bottom part is not going under. That is a horizontal asymptote. So from 0 up. So this is the underhand throw because we're going to have an overhand throw function. So gotta remember that. Okay, basic logistic. What? You're not going to remember that. Okay, so it's like this. The right hand goes up, the left hand goes down. It's like, I don't know. That kind of function. This one is very interesting because it has two asymptotes, two horizontal asymptotes. So this is right hand goes up, left hand goes down. Ranges from 0 to 1. Next one. This is the natural log function. All the log function is the overhand throw. So second period says they think of Kobe. Just, yeah. Okay. Nobody watches basketball. Okay, just wait. All right.
Next one. I'm just curious.
Why are you always looking so much ahead? I haven't finished my graph.
This is so loud.
Aaron, slow down.
Wait. This looks a little weird. This is the, I'm sorry. This is the overhand throw, and then the underhand throw is the e to the x. Oof. Okay, this one has a vertical asymptote at 0. You want to know?
Tell me how.
We're going to do it together so I don't look very weird
Oh,
by
no.
myself.
Oh my god, so
This is the Egyptian dance.
Oh yeah.
Oh, yeah. Okay, you just go like that.
Yo,
Let me see.
Just, this will be very popular for your homecoming dance.
Imagine,
Yes.
like you're doing your test and suddenly you're like, I can't remember.
You already know.
That's true. That's true. This one I will show you how to graph later, but basically, domain is all real numbers, but range is just the integer, therefore called the greatest integer function. Another way to write this is like that. Most of the calculator or things like that will show that.
Is that from like statistics?
I don't know, maybe. I have no idea. All right, last two, sine and cosine. Sine and cosine, you gotta know which one goes up and which one goes down. This one, this goes up, this goes down. Ooh, this man's so cool. Okay, so like this. And the range is stuck between -1 and 1. The last one, the cosine function. Okay, this is what I call the whatever function, because it's like someone asks you, you want burgers? Doesn't matter. I don't care. Whatever. So this is the I put my shoulder up, I don't care function. So cosine. Okay? All right. Let's see how much you remember.
Oh no.
Oh no?
I can't.
It's not that bad. Let us see. Okay. Show me which function is continuous. Which function is continuous? Okay, y equals x. What is
How do you do
This
that?
one.
No.
x cubed? Okay.
Wait, what about
This is like a charade. It's like you're doing a function. I'm like, which one are you trying to do?
Wait, one overhand.
Overhead e to the x. No. Overhead or log x.
Oh, under.
I see Caleb with one hand. He's trying to do something. I don't know what. Oh, square root x. Continuous. Which one is continuous? There's a lot of them that's continuous.
What's that? What the hell is that?
X squared?
Ew.
What is that, cosine?
One of those.
Look
Oh
at
wait.
this.
Wait, literally all of them could be, right?
No, not all of them are continuous.
So wait, no, this one can't.
I think everything except what? Reciprocal? This one and the Egyptian dance. They're the only two that's discontinuous. Okay. Huh? 1 over x, and
Oh, okay.
those are the only two that's discontinuous. Okay, let's try another one. Show me ones that have an absolute minimum. Absolute minimum. Okay, absolute value x. Blake always tries something and it's just like cosine. Cosine, yep. X squared?
Yeah.
Okay, x squared. Absolute value? That is not the absolute minimum. That's an asymptote. Asymptote is not a minimum.
Absolute one, there's only one, right? One.
Just like a lowest number. Okay, x squared? Yes.
But then what's local?
No, local is when there's more than one, then you can like find the like. It's like
Yeah,
bigger.
local, there's.
Absolute is like one.
Okay, yeah, yeah.
People over here, do you need another candy? You look like you're
Oh, I
tired.
have one.
What's on the? Okay, so which ones have absolute minimum? Okay, absolute value, square root. You have your sine and cosine, and square root. Square root has an absolute minimum. Square root is the absolute minimum is right there. Okay, let's try another one. Which ones are bounded? Which ones are bounded? Bounded means top and bottom. Cosine? Yeah. The sine? Yeah, cosine sine. What else?
Isn't that it?
No, those are bounded below. That's bounded below.
Oh,
Square, y square equals square, x square and absolute value, they're all bounded below because the top keeps going.
Oh.
Basic logistic. Yes. What is that? You transformed it. Bounded. Bounded means there's a top and a bottom. Top and a bottom. So let's see. This one, sine. Cosine sine and logistic. Yes. Those three. Let's try another one. Which one is always increasing? Always increasing. No.
This one.
Only increasing. Okay. X cubed. Is that x cubed? Yeah, x cubed.
Oh, this one.
Yes,
Yeah,
that's a natural log. This is square root. Wait, what are e to the x? Oh yeah, right, e to the x.
This one's the one with the
You-
boy who's the arm.
Oh
Yeah.
no, one of your. Oh no, yes, yeah, right. Why 1 over x? 1 over x is. Oh no, 1 over x is always decreasing, not increasing.
Wait, always increase.
Always increase. Always increase. Does not decrease. Y equals x, right? Did you guys forget that?
Huh?
The basic one. Y
Oh,
equals
I missed
x.
that one.
You did that one.
But I thought you were saying like always increase, so I was thinking something else.
Always increase that one. This one's always increasing. This is always increasing. Always increasing, always increasing, always increasing. The other ones are not. Good? All right. Okay, so make sure you memorize them by tomorrow. So you come in the door, I'm going to make you do the movements.
Wait, so you're gonna say the name and we have to say the name?
Yes, I'm going to say something like, show me e to the x. And then you're going to show me what e to the x looks like. Yeah.
Later.
Okay.
Wait, how many know it? Oh.
Wait, we have to know their
You don't have to know the names. I don't really care about the name. Just the equation.
Oh, so those are equations.
There's an equation here. All right, good. Okay. Now, no calculator. Analyze. Okay, square root x. Absolute value x. Absolute value x. Remember how it looks like. No calculator. Analyze that graph. You can do this. Okay, I think we ended at McKenna last time. So, units, what is the domain? Yes, all real numbers. So negative infinity to infinity. Allison, what's the range? 0 to infinity, do we include 0? Yes. Sherry, continuous or not continuous? It's good. Okay, Josh, interval of increasing and decreasing. Just give me increasing. Where's the increasing part? Okay, so this is the absolute value graph, and you're gonna decrease first and then increase. So what are the intervals for increasing? No? Yes? No? Okay, Blake, increasing.
Is it bracket 0, infinity?
Yes. And then Ashley, where's decreasing? Yes. Jennifer, even, odd, or neither? Good. Now, the way you prove this one is even. You do f of x equals f of negative x. So the original function is absolute value x. And then if you put in a negative, that's going to give you, both of them are going to give you x. So then that's an even function. Yes. Alana, bounded above, below, or bounded or not bounded? Which one? No. Bounded below. Yes, bounded below. There is an absolutely low point. So let's come back to Caleb. Where is the local or absolute extrema?
As an absolute minimum at 0.
Yes, 0, 0. And then Amelia, asymptotes. Oh, no, there is none. So this graph is continuous, and usually continuous graphs have no asymptotes. So this one has no asymptotes. All right, let's try another one. This one, again, no graphing calculator. Remember natural log x. Natural log, the overhand throw. The overhand throw. Alrighty, let's start with Trey. What is the domain?
0 to...
Do we include 0?
No.
Correct. Iris, what is the range? All real numbers, yes. So negative infinity to infinity. Junior, continuous or not continuous?
Continuous.
Evan, intervals are increasing, decreasing. Okay, from where? 0 to infinity. Aaron, even, odd, or neither? Yes, it is neither. Now, if you wanted to prove that it is not even or nor odd, f of x is not equal to f of negative x. So let's check. Natural log x and natural log negative x. Actually, we can't put negative numbers inside natural log. So this doesn't even make sense. It just won't even work. And then so the same thing if you're going to go ahead and prove odd, well, the first thing is already going to fail because you can't put negative number in. So it just won't work. So it's not possible to have some kind of symmetry. Next, Penny, boundedness. Bounded? No. Andy, you want to try?
Unbounded.
Yes, unbounded. So you can always check by looking at the range. The range is all real numbers, so it's unbounded. Sally, extrema. No. Yes, good job. None. Okay, McKenna, asymptote.
X equals 0.
Yes, x equals 0. All right. Next, review of your transformations. Okay. Yes, remember this from last year. So AHK. There's a lot of sigh of, oh, not this again. Okay, what does H do? Left and right. Okay, what does K do? Okay, up and down. And then what does A do? Stretch and compress, yes. Okay, so let's review. Vertical is going to be your up and down, so that has to do with K. When K is greater than 0, what happens? Up or down? Which one? Yeah, K. When K is greater than 0, is it going up or is it going down? Up, yes. And when K is less than 0, it's going to go down. When you see X minus H, which direction will you go? Right. Yeah, it's the opposite of the sign. If you see an X plus H, you're going to go to the left. And stretch and compress has to do with A, and this year we're going to be very specific. It's the vertical stretch and compress, because later on we're going to do a horizontal stretch and compress. It has to do with the absolute value of A, because the sign has some other reason for it. So absolute value of A when it's greater than 1 is a stretch or compress. Yes, it's going to be stretch, and it's going to be vertical stretch. And so when A is between 0 and 1, it's going to compress. We have two kinds of reflection. One is over the x-axis. The other one is over the y-axis. When it's over the x-axis, is the negative inside the function or is it outside the function? Okay, nobody remember at all. Okay, the negative is outside. And then y-axis, the negative is inside. Okay, so let's try this. We're going to look at some examples of equations. You're going to start from the parent function and then try to figure out what transformations happen. For example, this first one, f of x equals negative 2x squared plus 1. So the first thing you're going to ask yourself is, what is the parent function? What is the parent function? X squared. So y equals x squared. That means anything that's not an x squared is a transformation to the function. So, okay, this side. Give me a transformation. Someone from the 6 of you.
Reflect it on the x-axis.
Yes, reflect x-axis. Huh? Someone said something? Someone said up 1? Yes, up 1. And then one last one. Huh? Yes, it's already on there. Reflect. Stretch 2. Yes. And then we're going to say vertical because we're going to be specific this year. Okay, this side. The 6 of you. Oh, no, before that. What's the parent function? Y equals what? Square root x. Okay, so what's the transformation that happened? Huh? Compressed by 1/3? Okay, so let's say vertical compress. And then down 5. Good. Okay, how about this side? Because it would be just the 3 of you. This whole area. What is the parent function? Huh? Sine?
No, not sine.
Cosine. Cosine x. Transformation is a little bit more tricky. What do you guys think? Right 1. And then what?
Compress.
Yeah, vertical compress. 1/3, okay? So it's the number that's multiplied to the function, which is 1/3 times cosine.